This is a very interesting question to assess us on our understanding of displacement distance graph. So the answer to this question is A. A is the correct statement. And the reason for that is because particles K and M, they are a wavelength apart from each other. So particles that is a wavelength apart from each other, they are in phase, and therefore they are moving in the same direction, they have the same speed, and they are the same distance away from the rest position, which is 0. Now, option B is not a correct statement because on the horizontal axis here, we are plotting distance. So the distance between particle K and particle M is 4 cm. 4 cm is actually the wavelength instead of the time interval, which is called period. Option C, we have to repeat the technique to determine how the particles are moving. And we noted that the particles or the wave is moving towards the right. This means that the crest position here will be moving towards the right along with the wave. This means that for particle L, in time to come, it will have to move up so as to take over the crest position. And that's the reason why option C is not correct. Lastly, for option D, particles N and L, they are found at the same distance away from the rest position. Now, as we all know, particles at the crest and at the trough positions, they are momentarily at rest with zero kinetic energy. So they have the lowest amount of energy inside them. In contrast, particles at the rest position, over here and over here, these particles are moving with the fastest speed, having the highest kinetic energy. So when particles are away from the rest position, for example L and N, they will have the same amount of energy because they are found at the same displacement away from the rest position.